question is that a supported thing to be doing?
Shouldn't be.
So, so what we do, we make the packages up, we test them. If it's unlockable, we'll say you are allowed to do that, so you can unlock it. What we'd like you to do is stay on the surface, but for temporary relief, it allows you to get off the surface, update something, or you can actually keep it downgraded because you don't like the new version. And it is supported. However, if there is a problem with it, and we look into it and find actually there's an incompatibility with what you're doing and where you are, then we'll have to say, look, you've got to relock that, and then we'll fix the reason why you have unlocked it. Just an example here. So I've just done unlocking a DNS bind. So all I've done is use the change facet version bind lock, set it to false. Instead it's an image property, so it goes through all the packages on the system. So it's, there's actually only one package I care about that needs to be changed. Does it need to create a new boot environment? No, because we're just changing the user line thing. Create a backup one? Yeah, because we always take the backup. Blah, blah, blah. So it's all been done, and I say, okay, now I want to update bind to SIU4. So I update it to SIU4 and I'm done. So it allows you to independently update some components on your system. One of the best practices I've not put on this slide is once you've done, if you have unlocked something, use a command called pkg freeze to freeze it, and there's an option called -c. Put a comment to say why you've frozen it. I haven't mentioned it on these slides, but that's just a best practice there. Actuators.
Okay. Peter, so is there something that stops you from doing that with something like libc, or can you?
libc. So, the important thing about facet, you could go along and say pkg change facet version unlock libc. So it would go through all the packages and say, actually, does any package have a facet called version unlock libc? No. So whilst it will set it in the image, it actually has no appreciable effect on the package itself, because it's not defined in the package. You can only effectively set the facet for the package. It will only apply to those packages which have that facet within their manifest.
Oh, so this is controlled in some sense. If you haven't supplied a package with a facet DNS, then you can unlock it. So it's only the packages which have some facet label
Exactly.
in it.
Yeah.
So therefore, your kernel ones don't have any facets.
Correct.
In there.
Yeah.
So you just decide, okay, DNS, whatever software has it because it can.
Yeah.
Okay.
Yeah, and in general, what you find, you'll find,
Okay.
practically all the desktop ones have them, all the FOSS components have them, a select couple, I think there's about 5 packages in the OSNet Corporation that have it. There are arguments for making some more unlockable, but we looked at the number of times we patched them or fixed them, and it's arbitrary. It's, well, negligible, so we decided not to do those. It's not to say that we could do more, we probably could, but then as soon as we start to allow people to unlock, then we start to getting into dim sum patching and you don't know what you're doing on your system. Okay. So, actuators. So these are actions that will change a system when installed, which lie outside the predefined actions. So that allows a system to change when you install this particular binary. The system to do something, rather. So in this case, we have, first one, reboot needed. So when you update a driver, or the kernel, or libc, you want to reboot the system, because you need to reload the driver, reload the kernel, reload libc. So what we do is then tag it with reboot needed. And what happens there, when you're doing the install, it goes through, reboot needed. What that means is create a new boot environment, install and update in that new boot environment. Once that update is done, say you now need to reboot to make it active. That's all that effectively means. This one's from the E1000G driver. And the interesting bit about that, we have, during the build of the code, we look at the path of everything. So if anything under /kernel, we give them the reboot needed flag. So we don't tag each package and each binary. We've not gone through. So do we need to do that package or not? We've looked at the paths. We have a pkg modify transform that inserts that. So we do it on a path basis as opposed to a file name basis. Okay, that was fairly simple, I think. The more interesting one is how do we do class action scripts in a in an IPS world because there are things you might need to do that aren't covered by these actions. So typically what you do is have a script, the script does something. So what we do is, and you want that script to run in multiple different ways. So in the SVR4 world, you've got to interact with live upgrade, you've got to interact with an alternate route, you've got to interact with your running system. And you've got to test all those combinations. Or, in the IPS way, you say, okay, we just do it as a script, plug it into the SMF framework, do it once, you know it's going to work for every possible combination because of the way the system's all working together. Do you believe me?
Of course.
You should, because it's true. So, we have these actuators. Disable. Well, that says disable the specified service prior to removal of the package. I think that was quite simple. If the service is running, you want to remove the package that it's dependent on, just run that service with the disable flag. Refresh. So if you refresh the package or update the package, it will call refresh, which will go off and read any new properties, run a new script that you need to do. You need to restart the packages or whatever. After package operation, the redeemer can restart, new scripts can be done. So what you can call, because you're actually just calling into an SMF manifest, which says start, stop, refresh, whatever, you can then put your arbitrary script in there to do your arbitrary stuff, which could be changing your SMF properties, adding some files together, editing some files, whatever. But it's a script that you can run by hand before you actually put it on your system and test it in your user environment, plug it into your SMF stuff, and you're done. And I've got a brief example of one of those. So, actuators. So, example. When installing a new service, the manifest has to be imported. So you want to import the manifest into system. So what you can use is the system-defined system manifest import thing. All that does is look in lib svc manifest or var svc manifest. Says, are there any new ones in there? Yes, there are. Import them into the SMF repository. Machine reboots, those new services are up and running.
Is that still needed? I thought I saw something from Darren Moffat saying it wasn't needed anymore in 11.1. Everything magically gets reloaded, spotted. Maybe thinking
there is one called Manifest Early Boot that goes off and looks at stuff. I've not looked at that one.
I thought it was that one, but I may be mistaken.
Yeah, there's two actually. There's Manifest Import and there's Manifest Early Import. Okay. I've not looked at the Manifest Early Import, but part of that, I wouldn't be surprised whether we have done that or not. Okay, so what I'm going to do now is go a slight digression here and tell you about IDRs. Okay? Do you all know what an IDR is? Yeah? You love them, don't you? They're great things. So, basically, an IDR is a way we can deliver diagnostic, fix, or debug binaries to your system. One of the key things about why we do it in a packaging format, both for SVR4 and IPS, is A, it's trackable. We can see that you've got it on there as opposed to some arbitrary binaries. It prevents accidental upgrades. So if you've got an IDR in your system, you can't actually wipe out by accident. In fact, it's exactly what I've written there. Okay. So in an IPS world, an IDR delivers a couple of things. Delivers the packages requiring an update. So if you want an update to bind, we'll deliver a new version of bind. Okay. So one of the things we have a problem there is we have a system which is constrained. It's got incorporation. So incorporation defines the version string. It means that we can only apply that version. Yeah? So how do we get around that? We stick another two numbers on the end. So we're still working within that constraint, but now, as I mentioned earlier, we can, if anything, after that version string, we can control. So that's what we do with IDRs. So an IDR basically has that long FRI. If it's not long enough, we just stick another two numbers on the end of it. So that's a bit of fun and games there. And then what we've got to do is make sure that we don't accidentally overwrite that. So we deliver another incorporation. That incorporation then constrains that package to that whole IDR version. Yeah? So you can't move that package forward. Also, because that incorporation is outside of the system incorporation, nobody else knows about it, it means when you try to update your system, it goes, I'll update bind to the next version of bind. So it goes, I'll update bind to this. Hold on, I can't do that because I've got this incorporation here which says it has to be at this version, but I don't know about the incorporation. The upgrade will fail, thus preserves your accidental override of temporary relief or whatever. Does that make sense? So it's a trick we've used within well, it's not a trick, it's actually a way we've used the packaging utilities to deliver. So we have a look at the details of an IDR here. So again, it's got the same type of thing here. Name, package fMRI, name of it. So in this case, this was an IDR called 208, version 1. You see we've got rid of all that long thing. We've got the timestamp there. This one delivers an IDR on NFS. So you see we've got the whole fMRI there. That one is up to Solaris 11 SIU 6. And then we've tacked on the end the IDR number, 208, and the version there. That version is important because if we want to do a revision of that IDR, we just do 208 at 2, and we just deliver 2. So we can always update and upgrade the IDRs if need be. As I said, prevents the accidental update. We deliver IDRs as a package archive, so they're not in the support repositories. We deliver as P5P files. You can talk to P5P files, just do a PKG example here, PKG list, what's the contents of this, and you see it's got an IDR, 208, version 1, not installed or frozen or obsolete, and the version of the file system there. That's an IDR. So, the other thing about, one of the things, major feedbacks we took from customers for Solaris 10 was, well, I've got an IDR in my system, yeah, I'm happy with it, the patch is now available, it's a kernel patch, so what I've got to do is take off the IDR, reboot, install the kernel patch, reboot. Okay, so that's 2 reboots, big system, that's time. So one of the things we can do, and this is where I mentioned earlier, we've got how we use these from a sustaining point of view, we can use this as part of the package lifecycle. And we can use the package rename thing. So what we do, we track IDRs and the bug fixes they deliver, and when an SIU or bug patch or whatever you want to call it comes out, we say, actually, are there any IDRs that deliver all, does the SIU deliver all the fixes in some IDRs? If so, then those IDRs can be obsoleted. We can just say, get rid of them. So what we do is generate what we call a supersede package for the IDR. So all we do is then say, okay, grab a new version. So we use the IDR number, 161. I should have used the same example last time, sorry. Increment the version number 4, so we can always move forward. So we know that customers running IDR 161 at version 3, so version 4 is greater than 3. We also say, actually, this one's now renamed to this SIU, Solaris 11 Update 1, SIU 3. So what happens when the customer has IDR 161 at 3 installed on their system, they're running 11, whatever. When they want to upgrade to this one, it just silently allows them to upgrade, effectively only one reboot if that needs a reboot. So we actually just say, okay, from an IDR perspective, it's done and dusted. We know it's done and dusted. We'll allow you just to remove it on update. So it actually does save time. Is that cool?
So that's
I thought it was.
So I don't quite understand that. You say you've got IDR 161.3 installed in your system.
Yes.
And you say, okay, do an update of NFS. We say it's an NFS,
Yeah.
but NFS. So when it's going, so you just say update NFS, just make it simple. I mean, for update,
Yeah.
It'll go through the system. How does it know that? I don't quite understand.
So the solver will go for. So we'll just say we've got, just for sake of argument, we've got IDR at version 3, and we've got NFS installed. Ignore the rest. So you say, I want to do an update to the next SIU, which is that one. Okay? So if you try to do the update just to the NFS bit, it would go, I can't do that because I've got this IDR incorporation constraining me to this version. So we've got to get rid of that constraining incorporation. The way we do that, increment its version, so we've got IDR version 3 could go to IDR version 4, which is that one. We also then say, actually, this package has now been renamed to the incorporation that delivers the NFS package at the later version, which says effectively, if you worked all out combinatorics, it says, I need to go to version 4. Version 4 says I need to go to OSNet incorporation at blah, which then says to NFS thing. The actual end result is, well, that IDR has now gone away. We can just bypass it and delete it. So that's all done by the solver. Does that make more sense?
So you've actually got a real package in the SIU repository